My name is Jeff Norak. I'm president of SERVO-ROBOT Corporation, Milwaukee, Wisconsin. Today we're at APT Manufacturing Solutions in Hicksville, Ohio. And we're going to give you some information about robotic arc welding combined with 3D laser vision, where to use it, why to use it, how to use it. So the cell that we're working with today is a Cobot cell, where we have a large CRX FANUC robot, 25 kilogram, on a nice cart. Combined with the Fronius power source, we have a sensor from SERVO-ROBOT mounted out front of the robot torch with a modular mount. And here's the actual FujiCam. It's a 3D laser vision system. It projects a red laser onto the part, and with that we can do seam finding, seam tracking, and weld inspection. Some people say, how can you use a sensor or camera with a violent process like arc welding? Well, the sensor itself is a solid block of aluminum. It's got cooling inside. We use our regular airflow, or we can actually use forced air to cool it even more under very hot conditions. And then we have a nozzle on here that deflects some of the spatter. So yes, our camera can live in the spatter, the high frequency, the bright arc. It'll do quite well in that type of environment. We have a series of different parts. One is an automotive crossmember. Two clamshell components come together, and then you weld the lap fillet seam on both sides to form a channel. And the purpose here is to track that joint, because typically the variation in parts and fit up results in the seam not always being in the same place part after part. The sensor is in front of the wire, so as we track, we override the pre-programmed path and correct to keep the wire in the joint. Before we got to this point, we had to go into the Fruit software and then select the type of joint that we have in front of us. In this case, we get a curved lap fillet. That's part of a task, a vision task. Along with that, you provided typical thicknesses and gap. And that's all the information we need to track that joint in real time. And again, send the offset information and gap value to the robot so you can actually do adaptive welding if required. Now we're going to move into a different area of pipe welding, and the part we're going to use is what we call a saddle joint, where a coped tube here mates up against the other pipe, forms a very complex joint. It's tough to program because you need to keep your torch and work angles exactly correct. So we have a couple of solutions for this. Initially on the programming side is automatic teach for a Cobot called ATC. Instead of having to program the path ahead of time, you give it a couple of points. So as we scan around, we're acquiring a 3D map, and we use our laser to actually program from scratch. From this, we create a brand new teach-pendant program. But it gives you about 90% start on the actual program required, which could save quite a bit of time. We've also just developed automatic joint recognition. So as you're going around and scanning that first time, our system is automatically recognizing the type of joint and fills that information in the vision task. The goal here is to make it simpler for Cobot users, which are typically shops that don't have a skilled robot programmer. You're taking a welder and putting him in front of a robot, and to simplify the programming in all aspects will save time and improve how quickly they can start to use the system. So our last part we're going to show today is a fuel tank, and it's made from aluminum, which sometimes can be shiny, but our laser vision can handle that. Now this is the FujiCam real-time seam tracker that we use with the FANUC robot. The seam tracker can also do seam finding. The reason we're using seam finding is this part in the real world would shift part to part. And with aluminum, there's really no touch sensing. Because of the conductivity, it's not really effective, so the laser is even more important on components made of aluminum. The sensor is going to come down and search in 3 locations to get a reference. That allows us to do a 6D shift, which means the part can shift left, right, tilt, any motion of that part. We capture that variation. So laser comes on as we get close, and this will take the first search point. It takes a second search point. It only takes less than a second to capture that location, pass it to the robot via the high-speed Ethernet interface cable and software. So now we have our reference. Now we come over to the start location, and now the wire will come down. We'll go through the pre-programmed path. We call it offline seam finding. You find the location, the offset ahead of time, pass that information to the robot. The robot then runs its programmed path with those offsets. We're capturing, again, location and gap information. So if you had a gap and you knew how to adjust for that, you could do adaptive welding, change the current, travel speed, you could weave. Those are all available in the adaptive world. But this again shows the flexibility of this system to do seam finding, seam tracking, and automatic teach.